we're going to calculate the standard enthalpy of reaction for this, the production of acetylene, C2H2 gas, from solid carbon and hydrogen gas. You can't actually do the reaction the way it's written, but I do have two reasons for doing this. One, to show you how to do a problem like this, and two, I'm going to use this result in a later podcast. You need this information. These are three thermochemical equations you've been given, and we have to find a way to turn them into the desired equation. Now, recall something we did before. We took two equations, the top two, and we added them together to get the overall reaction, which is the bottom one. And when we added them together, the carbon monoxide gas was common on both sides, so we removed it like it's a mathematical variable. And then, in order to get the standard enthalpy of reaction for the bottom, we added up the top two. So we have to find a way to add those bottom three up, such that the chemical equations will add up to the desired equation. And when that happens, we'll be able to add the modified standard enthalpies of reaction to get the desired one. Now, if you look at those bottom three equations, there appears to be too much information in it. There's no O2 in the desired equation, but there is in all three of these. Same problem with CO2. Same problem with H2O. Well, there is some information that we need. We need solid carbon. It's in the middle equation. We need H2 gas. It's in the bottom equation. And we need acetylene. It's in the top equation. So you have to trust that the information's been given to you in such a way that it will allow you to solve the problem. So the things that we don't want, they will cancel out. And the things we do want will be there when we're done. I'm going to start with the solid carbon in the desired equation because it's on the left, that's all. And I see that my middle equation has solid carbon in it. So let's work with the middle thermochemical equation. You have to focus on one thing at a time. Now, what are we going to do to that? Well, another reminder. There were basic thermochemical manipulations. The top set with the blue standard enthalpies of reaction, that one was done in order to show you that if you take the first one and double everything in it, you double the enthalpy change. So there's one manipulation. The bottom sets of equations, the ones with the red standard enthalpies of reaction, if you reverse the reaction, you then change the sign on the standard enthalpy of reaction. So we have to keep those two things in mind. So let's look at the bottom equation. That's a given. Well, I don't have to reverse it because when I'm done, I want solid carbon as a reactant, and it's already a reactant. But I do need twice as much carbon. So I multiply all those coefficients by 2. Which means I then take the standard enthalpy of reaction and multiply it by 2. Alright, so that bottom one, let's set it aside. We'll bring it back later. What to do next? I'll go for the H2 gas, and then we'll do the acetylene last. The bottom equation has H2 gas in it. So let's work with that one. Now H2 gas, I want it to be a reactant. It's a reactant. Good. But I only want one of them. So I'm going to multiply all the coefficients by a half. So that'll get me my 1H2. And if I multiplied the coefficient by a half, I have half as much stuff. So I multiply the standard enthalpy of reaction by a half. That bottom one, set it aside. I'll come back to it. Now there's only one thing remaining, and that's the acetylene gas. So luckily, the only equation I have left has acetylene in it. So let's work with that. Now, I want acetylene as a product, but that's a reactant. So I'm going to reverse the reaction. Now I have acetylene as a product. Good. But I only want 1 mole of acetylene as a product. So I take that bottom reaction and multiply all the coefficients by 1/2. Then, as to the enthalpy change, I see that I reversed the reaction, so I have to take the given value originally, minus 2598.8 kilojoules, and change the sign to a positive because I reversed the reaction. And then, after I did that, I took half as much stuff. So then I take the standard enthalpy of reaction and multiply it by 1/2 to get the bottom value. So let's see where we are. Right, this was the original information. These were the equations we were given. And now, this is what we turned them into. So what the heck do we do with this? Well, remember, we can add up equations to get an overall equation. So let's do that. Let's add up the 3 equations that we modified and see what we get. All right, I have 2 carbon dioxide gas as a reactant, 2 carbon dioxide gas as a product. I can remove those. Same thing with liquid water. And then I have 2.5 O2s, which is 5/2. So the O2s cancels. So what's remaining? From the top one, 2 solid carbon reactant, H2 gas reactant, acetylene product. Well, those 3 equations added up to the one I'm looking for. Therefore, we can take these 3 standard enthalpies of reaction, these new values, add them up, and there's the standard enthalpy of reaction for this, positive 226.6 kilojoules. It's endothermic.